This question says, let f of x equal square root x plus 3 and g of x equal x squared minus x. Find and simplify the expression. We have f plus g of 1. I want to find, f plus g of 1. There are two different ways I could go about doing this. I could first substitute 1 into f, substitute 1 into g, and then add my answers together. So let's try that first. Substituting a 1 in for f would give me square root of 1 plus 3, which is square root of 4, and that's 2. Substituting a 1 into g would give me 1 squared minus 1, which is 1 minus 1, and that's 0. If I add those two together, I get 2 plus 0, and that gives me 2. So that's one way to do this problem. The other way to do the problem is, since we're trying to find f plus g of 1, first I need to find f plus g of x. So this means I want to add the function f of x to the function g of x. That gives me square root of x plus 3 plus x squared minus x. And once we've simplified, and this is completely simplified since there are no like terms, I can then substitute the 1 into that function. So that would be 1 plus square root of 1 plus 3 plus 1 squared minus 1. That's square root of 4 plus 1 minus 1. Square root of 4 is 2. 1 minus 1 was 0. And 2 plus 0 is 2. So either way we get 2. The first question says, use the graph to evaluate the given expressions or state that it is undefined. Part A. What is the value of f plus g of 4? Before we start working this out, let's make sure we understand this notation. We have f plus g of 4. The f plus g part is the name of the function, but not only the name, but how the function is constructed. You have some function named f and some function named g, and you construct f plus g by adding f and g together. So to start working this problem out, we're going to rewrite the original problem based on this definition here. F plus g of 4 is the same thing as f of 4 plus g of 4. Now we can work out these individual expressions. F of 4 means that the x value is 4, and we're looking for the y value in the function called f. So let's go over to this graph, and we've got two curves. One of them is labeled f, this red one is labeled f, and the blue one is labeled g. So if my x value is 4, and I walk my way up to the function, I can see that the y value is 2. So f of 4 is 2. Then I can do the same thing with g. My x value is 4. I walk my way up to the function, and then I can go over to the y scale to get that y value of 3. Then you're going to add those two answers together. Because this function is f plus g, that's why we're adding those two together to get 5. So f plus g of 4 is 5. Part B. What is the value of f minus g? So just like the previous example, f minus g is the name, but also how the function is constructed. We're going to take the function called f and subtract the function called g. So we can rewrite this as f of negative 4 minus g of negative 4. we can figure out those values from the graph. F of -4, the x is -4. I'm going to go up to the graph of f and over, and we've got a y value of 2. Do the same thing for g of -4. We have g of -4, go up to that y value, and over, we have 1. G of -4 is 1. Then we're going to subtract those two values, and 2 minus 1 is 1. So for part B, f minus g of -4 is 1. Part C, what is the value of g times g of 4? So g written next to g is multiplication, g multiplied by g. So we're going to rewrite this as g of 4 times g of 4. We're going to use our graph. So we have an x value of 4. We're going to go up to the graph of g and over, and we've got a y value of 3. So g of 4 is 3, g of 4 is 3. We're going to multiply those answers together to get 9. Part D, what is the value of f over g of 4? So let's rewrite that as f of 4 divided by g of 4. We're going to use the graph to figure out what f of 4 is. For my x value of 4, go up to the graph, and I've got a y value of 2. So that goes in the numerator. G of 4, have x value of 4, go up to the graph and over, have a y value of 3. That goes in the denominator. So f over g of 4 is 2/3. Thank you for checking out my videos. Have a great day. For this example, we have, for the pair of functions defined, find f plus g, f minus g, f times g, and f divided by g. Give the domain of each. So our functions, f of x equals x squared minus 4, and g of x equals 3x plus 9. First thing we want to find is f plus g. So the name is exactly how we do it, how we construct it. F plus g of x is the same thing as f of x plus g of x. And f of x is x squared minus 4, and I want to add that to 3x plus 9. Then we want to simplify by combining like terms. That would give me x squared plus 3x plus 5. So f plus g is x squared plus 3x plus 5. Then it says, find the domain of f plus g. So we need to go back a little bit and first think about what is the domain of these individual functions. So for f is x squared minus 4, and x squared minus 4 is a polynomial function. So that's going to have a domain of -infinity to infinity. And g of x equal 3x plus 9 is also a polynomial function, and it'll have a domain of -infinity to infinity. When you take two polynomial functions and add them together, it creates another polynomial function which has a domain of all real numbers, or negative infinity to infinity. So that is the answer for domain of f plus g, negative infinity to infinity. So moving on to the next part, we want to find f minus g of x. F minus g of x is f of x minus g of x. F of x is x squared minus 4. And I want to subtract g of x. Notice I'm putting parentheses around g of x to make sure I'm subtracting the whole function. And when I simplify this, I need to distribute that negative sign. Make it minus 3x minus 9, and then combine like terms. That would give me x squared minus 3x minus 13. So that is f minus g. And then we want to find the domain of f minus g. So just like the previous example, when you take two polynomial functions and you subtract them, you're going to create a new polynomial function. So the domain of that function will be negative infinity to infinity as well. The next part is f times g of x. Well, f times g of x is the same thing as f of x times g of x. So that's going to be x squared minus 4 times 3x plus 9. Notice I put parentheses around both of those because I want to multiply the whole function f times the whole function g. And now we're going to multiply that out with the FOIL method, or if you have another method of multiplying you like, you can do it that way. So that would give me 3x cubed plus 9x squared minus 12x minus 36. There are no like terms there, so this is as far as we can go. On the next part, we want to find the domain of f times g. Just like the previous examples, when you take two polynomial functions and you multiply them, that's going to create a new polynomial function, and the domain is negative infinity to infinity, or all real numbers. The next part, f over g of x. F over g of x is the same thing as f of x over g of x. So I'm going to have x squared minus 4 in the numerator and 3x plus 9 in the denominator. When you simplify expressions like this is a rational expression, you want to factor and see if there are any common factors that you would cancel out. Your numerator here can factor, it's a difference of squares, x plus 2x minus 2. Your denominator, both of these terms have a common 3, so I can factor out a greatest common factor of 3. So we get 3 times x plus 3, and I notice that there are not any common factors, so this is as far as you would need to go. It is in lowest terms or simplest form. The next part says find the domain of f over g. So this one is different than the previous examples. In all three previous examples, adding, subtracting, and multiplying created another polynomial function. But when you divide two polynomials, you don't create a polynomial function, you create a rational function. With rational functions, we're worried about the denominator being 0. So to find the domain, we're going to take that denominator of 3x plus 9, set it equal to 0, and solve. So we're subtracting 9 on both sides. We get 3x equals 9. 3x equals 9. We'll divide by 3 on both sides and get x is equal to 3. The value of x equals 3 is going to cause the denominator to equal 0. And when you divide by 0, that's something that's undefined. So we don't want the value of 3 in our domain. It has to be excluded from the domain. So if we're thinking on our number line, we would mark 3 on our number line. That value is excluded, which is why I wrote it with an open circle, but we're going to include every other number on the number line. So using this picture, we can draw the interval notation. I want to draw an interval for the left side here, the shaded region on the left side. That goes from -infinity to 3. And I want to write an interval for the right-hand side, the shaded region. That goes from 3 to infinity. And I'll put the union sign between those two. So that's our domain of f over g. -infinity to 3, union with 3 to infinity. This example says find f of g of x for the indicated functions and simplify. We're given f of x is equal to 3x plus 2, and g of x is equal to 8 over x plus 2. This operation, f of g of x, is called composition. And what it means is substituting one function inside of another function. Let me rewrite this. F of g of x means that you're going to substitute g inside of f. So the inside function is always the function that is second or after the composition symbol. The outside function is the one that's before the composition symbol. So we're going to substitute g of x inside of f of x. G of x was given as 8 over x plus 2. So that's what I'm going to be substituting in for f. Everywhere I see an x, I'm going to replace that x with 8 over x plus 2. So that's 3 times 8 over x plus 2 plus 2. I can simplify this by multiplying. The 3 is the same thing as 3 over 1, and that would give me 24 over x plus 2 plus 2. To continue to simplify this, we want to combine these two separate terms into a single fraction. So we would need to get a common denominator to make that happen. So the first fraction has a denominator of x plus 2, and we want the other term to have a denominator of x plus 2. So I'm going to treat the 2 as 2 over 1 and multiply by x plus 2 over x plus 2 so that we have common denominator of x plus 2. The first fraction stays the same, 24 over x plus 2. The second fraction, I will distribute this 2 to both those terms in the numerator, which will give me 2x plus 4 over x plus 2. And now that I have a common denominator, I can combine the fractions and combine the like terms in the numerator would give me 2x plus 28. And my solution is 2x plus 28 over x plus 2. Evaluate the composite function given that f of x equals 5x plus 4 and h of x equals square root of x plus 3. We want to find f composed with h of 1. So I'm going to show you two different ways that you can get to this answer. So the first way has you doing kind of a two-step process. And the first step in the process would be that you would build the function that's being described right here, f composed with h of x. Then once you've built that function, then you're going to do your substitution, which I always say plug. So that's when you're going to plug in or substitute in that value of 1. So that's the first way I'm going to show you how to do it. And the second way is going to follow the symbols. So let's start off with the first way. So we're going to start by building this function that's being described here. So I want to do f composed with h of x. This operation of composition is substituting one function inside of another function. So we're substituting h inside of f. So we're going to substitute this square root in for that x. That's going to give us 5 square root of x plus 3 plus 4. There's not really any major simplification we can do here, so we're going to stop. So we've built the function. That was step 1. Then we're going to evaluate or plug. That's f composed with h of 1. So that means in place of this x, we substitute a 1. And that's going to be 5 square root of 1 plus 4 plus 4. And we'll simplify square root. Excuse me, I made a mistake there. I wrote, instead of the 3, I wrote 4. So let me fix that. So let's change that to a 3. We get square root of 4. Square root of 4 is 2. 5 times 2 is 10. And 10 plus 4 is 14. So we've gotten that f composed with h of 1 is 14. So that's one way to get your answer. The second way is going to be to follow the symbols that you have. So we have f composed with h of 1. And we want to keep in mind that this composition is substituting one function inside of the other function. So I can rewrite it in this way, f of h of 1. And now on the inside, I'm going to calculate h of 1. H of 1 is evaluating h at 1, plugging a 1 into h. So that is the square root of 1 plus 3. And the square root of 1 plus 3 is the square root of 4. And the square root of 4 we know to be 2. And then we're going to work out f of 2. That's substituting a 2 inside of f. So 2 in for that function there. That's 5 times 2 plus 4. That's 10 plus 4, which is 14. So we were able to work out f composed with h of 1 to be 14. So now you've seen two different ways that you can work out this evaluation of a composite or composition of functions. Thank you for checking out my videos. Have a great day.